Hello, welcome to Leeds PHP. It's 2021, a new year. Thank you for joining us. So today we've got two great talks. We'll start off with Zvonimir talking about Git reset. We'll take a short break after that, about 20 past, and then we'll go into Chris's talk about testing in the real world after that. And then if you'd like to hang around after that, we'll be in the social track where we'll just have a bit of a drink and a chat if you'd like to hang around. Thank you to our sponsors who support this event. We've got BJSS, who are a consultancy based in Leeds and other places. Searchability, who are a recruitment agency, and Bruntwood, who usually provide us with our venue free of charge. And also thanks to Big Orange Heart, who provide this brilliant platform for us to use. If you'd have come to one of our events before we had this platform, it was a mess. So thank you to them. Their mission, a charity whose mission it is to support and promote positive well-being and mental health within remote working communities, which I think is something we can all get behind at the moment. So if you want to support this event, go and give them some money. I'm sure they would appreciate it. We also have a Slack instance now. If you'd like to join that, the URL is there. I'll also stick that in the chat in a bit as well. So please join us on there and feel free to ask questions and just general chat on there as well. We're also looking for speakers for the rest of the year. So if you've got a talk that you'd like to share, or if you've got anything that you want to share, something you've been working on that's been cool, we'll do either long slots that are up to an hour or shorter slots. If you just got a quicker thing you'd like to share that might not take a full slot, please get in touch. We'd love to have you on. So we'll get on to our first talk now. So is Zvonimir around?
Okay. Hello, everybody. Give me a second to share my screen and do the technicalities. Okay. So, yeah. I hope you can all see my screen and hear me. So I will just start. Yeah. Hello. PHP Leeds PHP. This is glad to be here. This is my second time here, and for the second time I'm going to talk about Git, but this time I'm going to talk about the notorious reset command. I say notorious because it does have this kind of reputation for being a bit dangerous, but as it usually goes with the reputation, it's a bit exaggerated. So before we take a look at the reset command today, we're going to take a look at something that is called the trees of Git, or I like to call them areas, because the reset command actually works by manipulating the content in these areas. So it's useful that we take a look at how they work, what they are, and then we're going to take a look at the three modes of the reset command, which are the soft, mixed, and the hard mode of the reset command. So this is a lightning talk, so we don't have a lot of time, so let's dive right into it. The trees of Git, or how I like to call them, the areas of Git. So I'm sure all of you probably heard about this thing called the working directory, staging area, and the .git repository. So what are they? Working directory, this is the file system on your computer. This is the project files on your computer. .git repository, this is, you can think of it as Git's data storage. This is the place where Git keeps all the data objects or data structures it needs to recreate the state of your project for some given point in time, which is a commit, right? And actually, it is just a folder. It is a folder called .git, so it's a hidden folder. But if you go into your project and use the tree command, you can find this folder, so it's there. And so let's now take a look at how these areas work. The staging area is kind of in between, so now we'll see how this works and what is the staging area also, why it is useful. So when you make some changes to your files, let's say we add some changes to our index.php file, you do those changes on your working directory, right? You edited your file on the file system on your computer. Git is not aware of this just yet. Once you use the add command, Git will become aware of these changes, and Git will put those changes in the staging area. This is why we call this step staging your changes. Now, this staging area, as I said, is kind of like a step in between of making some changes and saving them to your history, to your .git repository, or persisting them, let's say. And the reason why we have this middle step is because it's actually pretty useful, because this allows you to actually inspect the changes you added to the staging area, because the staging area, you can think of it as a preview of your next commit. So now you can take a look at how these changes look. And if you're happy with how they look, you can go to the next step, which is to use the commit command, put those changes in the Git repository, at which point Git will take those changes and make a commit out of them. And once Git puts them in the .git repository, these changes will kind of be there forever. Git will really rarely delete anything from the .git repository. So as I said, the staging area, it's useful because it allows you to fine-tune your commits. So for example, let's say you add some changes to the staging area, you inspect them and you say, this doesn't look how I really want it. You can take those changes back to the working directory, put some other changes to the staging area. And once you are happy with how your staging area looks like, then you use the commit command, at which point Git will make a commit out of those changes. So it is kind of like this step in between, but it is really useful when it comes to in a practical sense, right? Now, let's take a look at what will happen if we add some more changes to our index.php file. Again, as I said, when we make some changes to our files, we do this in working directory, right? On our file system on our computer. So now we have created this new version of index.php. Let's call it version 2. Again, Git is not aware of that just yet, but once we type the git status command, what the status command will do, it will take a look at the content of these areas, of the working directory, staging area, and the .git repository, and it will do some comparison. And here, the status command sees that in the working directory, you have this version 2 of your file, but in the staging area and the .git repository, you have the old version 1 of your file, of your index.php file. So the status command will tell you, well, on this branch called master, which now it will be called main. I need to update my slides. So on the branch called master or main, you have these changes that are not staged for commit. In other words, you have added some changes to your working directory, but you haven't yet used the add command to stage those changes. So let's do that right now, right? Now we type git add index.php. Again, at this point, the add command will take the content of your working directory and push it into the staging area. So now if you type git status, it will again take a look at these areas and examine the content of them. It will compare it, and then it will see that in the working directory and in the staging area, you have this version 2 of your index.php file, while in the .git repository, you still have this old version 1. So what this means is you added some changes to the working directory, you staged them, you did use the add command to stage those changes, but you haven't yet done the, let's call it the last step, the final step in our workflow, which is usually the commit command, right? So this is what git status is telling you. There are some changes that are ready to be committed. So they are staged and ready to be committed. And then finally, if we commit our changes, again, Git will take the content of our staging area and make a commit out of them, persist those changes in Git's data storage, put it in our history, right? So now, again, all our areas are sick. They all have this version 2 of our file. But what about version 1, right? Well, like I said, once you kind of persist, once you do a commit, once you persist changes to the .git repository, they are kind of there forever. So version 1 is still there, and you see version 2 has this pointer to version 1. So it knows this version was here before me. This version is my ancestor, or my father, or my mother, or my parent, however you want to call it. Now, the way this works is that Git has this kind of special pointer called head, and this head pointer is pointing to the current version in the .git repository. So even though we have this version 1 and version 2 in our .git repository, Git knows that the version 2 is the current version. And this is why it uses this head pointer. And when the status command takes a look at your .git repository, it only cares about the current version. So for the status command, it looks like this, right? So in this display, I'm only displaying what the status command sees, and that is the current version in your .git repository. And it will compare this version to the versions in working directory in the staging area. So now this is how these working directory, staging area, and .git repository work with our usual git add, git commit, and git status commands, which are like 90% of the time we use this command in our workflow. So now that we know all that, let's take a look at the actual git reset command. Let's take a look at the soft mode first. So back to our situation. So we have added some changes, created the version 1 of our index.php file, staged those changes, committed them, then we added some more changes, staged them, committed them. So now we have this version 2 in all our areas. And now we type git reset -- soft head ~1. --soft is telling the reset command to use the soft mode, and head -1 is telling it to move the head pointer one step back. If it was head -2, it would be 2 steps back. If it was head -10, it would be 10 steps back. And yeah, you get the picture. So what will happen is git reset soft will only do one step. And this step is the same with all the modes of the reset command. So it will go to the .git repository, and then it will move the head pointer. In our case, it will move it one step back. So when it moves it one step back, the head pointer now will point to the version 1 of our index.php file. So now the current version in the .git repository is version 1. So if we now type git status, the status command will take a look at these areas, and to the status command, it will look like as if we added some changes to our index.php, hence creating the version 2. We staged those changes, but we didn't yet use the commit command to actually commit them. And this is what it is telling us, right? It is telling us there are some changes that are staged and they are ready to be committed. So you see, it kind of looks like as if we went one step back in time, as if we uncommitted our changes, right? But one thing that is really important to note here is we didn't lost any data, right? Version 2 is in our working directory and in a staging area. Version 1 of our file is in the .git repository, right? So we didn't lose any versions, we didn't lose any data. So git reset soft is perfectly safe to use. And with that, we can move to the mixed mode. Now, mixed mode is also the default mode. So if you omit the mixed flag, git reset will use the mixed mode. Again, we are back to our situation with the version 2 in all of our areas. Now we type git reset mixed mode, head -1, again, means the same thing. So first step is the same with all the modes of the reset command. Git reset will go to the .git repository and it will move the head pointer. In this case, it moves it one step back. So now it points to the version 1 of index.php. So the current version in our .git repository is version 1. Now the reset mixed mode will do the second step, which is to make the staging area look like .git repository. So it will take the changes, the current version from the .git repository, and put it into the staging area. In other words, as I said, it will make the staging area look like the .git repository. So this is the end result of the git reset command in the mixed mode. If we type git status now, again, git status will take a look at these areas, and to git status command, it will look like as if we added some changes to our index.php file in the working directory, hence creating the version 2 of our file, but we haven't yet used the add command to stage it, nor did we use the commit command to commit it. So it kind of looks like as if we went 2 steps back in time, we uncommitted our changes, and then we unstaged our changes. But again, important to note here is version 2 of our file is in the working directory. Version 1 is in the staging area and the .git repository. So again, we have both of our versions, right? We didn't lose any data. So git reset mixed is, again, perfectly safe for you to use. You don't lose any data with it. And with that, we can move to the hard mode, right? Now we're going to lose some data finally. But let's see. Again, back to our situation. Version 2 is in all our areas. Version 1 was committed before. It's still in the .git repository, but the current version is version 2. So now we type git reset --hard head -1. So again, the first step, always the same. Git reset goes to the .git repository, moves the head pointer, in our case, one step back. So now the current version in the .git repository is version 1. Second step is the same as in the mixed mode. So git reset hard will make the staging area look like the .git repository. And the third and final step that only the hard mode does is git reset hard will make the working directory look like staging area. So now, once the git reset hard is done, the end result is working directory and staging area and the .git repository, they all have version 1 of our file. So if we would type now git status, it would tell us there's nothing to be committed, nothing staged, because our areas are in sync, they all have version 1. So I guess we have finally lost some data, right? We lost version 2. Not really, because if you remember, and of course you do because everybody's paying attention, as I said, once you kind of do a commit, once you persist changes to the .git repository, they're kind of there forever. And version 2 of our file is still there, is still in the .git repository because we did actually commit it. but it is kind of hard to reach, because you see version 2 has a pointer to version 1, but version 1 doesn't have a pointer to version 2. Actually, version 1 doesn't even know that there's a version 2, right? So it is going to be hard to reach if you get into this situation. But if you do get into this situation, then what you need to do is keep calm and Google git reflog, or you can Google it right now or write it down somewhere, because one day git reflog will save your life. And by using the git reflog and some black magic with Git, you can actually get to the version 2, you can retrieve it, so you can still retrieve those changes, so you didn't actually lose data even with this hard mode of the reset command. But you did put yourself in a uncomfortable situation, and now you have to do some black magic stuff. But just remember, git reflog is the thing you need. Okay, so now we went over all 3 modes of reset, and we still didn't lose any data, right? So what's this all about? Because everybody says git reset is dangerous, you will lose your data. Well, there is a situation when git reset can be dangerous. So now is a good time to actually, if up until now you were not paying attention, please now pay some attention, because again, this could save your life. So git reset can be dangerous, and it can be dangerous in the hard mode. And this is one scenario where it can cause you to really lose your data. So pay attention. Again, we are back to our situation. Version 2 is in all our areas. Version 1 is in the .git repository, but the version 2 is the current version. Now, we add some more changes to our index.php, hence creating version 3 of our file. And now we say git reset hard head -1. First step of the reset command is to go to the .git repository, move the head pointer, in our case, move it 1 step back. So the current version in the .git repository now is version 1. Second step, git reset will make the staging area look like the .git repository. And the third, final step is it will make the working directory look like the staging area. So now this is the end result of the git reset hard. And again, we have version 1 in all our areas. Version 2 is still in the .git repository, but as I said, it is kind of hard to reach. You made your life difficult if you need to reach it. But version 3 is nowhere to be found, because we never committed it, right? We never used the commit command to actually persist it to Git data storage. So it is just simply not there. So all those changes that you did on version 3 now will be lost in time like tears in the rain. Time to recap. So git reset soft will do only one thing and one thing only. It will move the head pointer. In our case, it would move it 1 step back. Git reset mixed will do the second step, which is to make the staging area look like the .git repository. And git reset hard, the only potentially dangerous mode of the reset command, so you need to be extra careful with it. It will do the third and final step, and that is to make the working directory look like the staging area. And I'm not done yet, right? I still have some more things to say. Yeah, just a little add-on to all of this. In order to explain the git reset, I did kind of simplify some things. So just so you know, to keep the record straight, the head pointer actually doesn't point directly to a commit or your file. It points to a branch pointer, or in Git they call it a reference, and a branch pointer. The branch pointer then points to your commit, right? But the reset command works as I did describe. Another thing is, Git doesn't use these things like version 1, version 2, version 3 to version your files. Git uses something that is called a checksum header. And in reality, there are these things called blob objects that represent the content of your files. And they have these checksum headers. And Git can use these checksum headers to indicate that there was a version change. So different checksum headers mean different content of your files. So this is how Git versions your files. And one thing about these checksum headers is you can use them to as an argument to the reset command. So instead of telling the reset command, hey, move the head pointer 5 steps back or 1 step back or 100 steps back, you can tell it move the head pointer to point to this exact commit. And every commit in Git has a unique checksum header. And the last thing that you probably all are aware of, we can put multiple changes from multiple files into one commit. We pack them into one commit. But again, the reset command works exactly the same. I just used one file in my example to keep it simple for my explanation. So now I'm truly over and truly done. Thank you all for tuning in, for listening. Thank you, Mark and Dan, for hosting and having me. And yeah, if you have any questions, I guess we do have some time. So yeah, I'm here at your disposition.
Zvonimir, if anyone has any questions, just put them in the chat now and we'll relay them back. So I'll just give that a couple of minutes to see if anyone has anything. Yeah, it was interesting talk. Thanks for that. Always, I quite enjoy going into the ref log if I make a mistake. Just makes me feel like I'm going under the hood.
I've never dabbled with the ref log, but now I'm going to.
No, it's great. Especially if you like rebasing and force pushing, you might get into the stage where you have to dig into it.
Yeah.
So a question from Dorothy: how does this apply? So does this apply to whole commits, or can it apply to individual files?
Oh yeah, it does apply. Like I said at the end, like I used one file just to keep it simple, but this works the same if in one commit you have multiple files. The point is that Git the head pointer moves, and then it will revert, undo the changes. If in your commit, like you had you committed 3 files, and then you use the git reset soft, it will undo that commit, so you will have all the 3 files back in your staging area. So yeah, it applies to whole commits. I just to keep it simple, I made it like one file, one commit. But yeah, of course you can have multiple files in one commit.
You could pull a file back out of a different commit, though, couldn't you? With git check out the commit hash in the file.
Yeah, to be honest, I know you can do that from, like, if you have it in the staging area, you can pull it back to the working directory, like unstaged, a single file. I'm not sure, like, can you extract like one file out of the commit, just one file to the staging area? I mean, it's Git, so you can do almost know enough about Git, but yeah, I would have to see how exactly to do that.
So Chris asks, how often do you use a ref log and why?
Yeah, so as I said, that case where we did use the git reset hard, and we kind of lost our version 1 that we previously committed, or the version 2, and it was really hard to trace because, as I said, version 2 had a pointer to the version 1, because every commit in Git has a pointer to its parent, but a parent doesn't have a pointer to its children, so it's a one-way street, like if you look at Git's graph. So sometimes you move the head pointer, and then you can go only in one way, and your commit can be on another direction, and then you use the git reflog. And git reflog is actually storing the checks and headers of all the commits where your head was pointing to. So if before the reset your head was pointing to some commit, and then you did some reset, and now your head is pointing to God knows where, if you go to the git reflog, you will find the checks and header of that commit that you lost, right? You thought it's hard to reach, and then you can use the actual checkout command to point the head pointer to that exact commit, and then your project will be at that state. I'm not sure if you were able to follow me, but Google, there are some articles on git reflog, pretty good ones. You should find it, but yeah, it will explain it maybe a bit better.
You can lose it.
I'll talk on it, but yeah.
Yeah, you can use it if you lose files or lose stuff during a rebase as well, can't you? You can go back and see all the commits and cherry pick them back into.
Yeah. Whenever you do something like you do a rebase or reset and nothing is like you wanted it to, right? Then you use the git reflog, and you will see this collection of head was here at this commit and this commit, and then you can go back to the commit you were previously on before you did or one thing you can do even without the reflog, before you do something with Git that's like dangerous, you're going to do some rebase, right? And I copy and paste the checksum header of the commit you are currently on, like git log and the commit you are right now on. Do your rebase, do whatever, and if it doesn't work as it needs to, then you can use the checkout command and give it as an argument, give it that checksum header, and you will be back to the state you were before you did the tricky situation. So actually, it is really hard to really lose data in Git, even though contrary to popular belief. But yeah, sometimes it can be hard to reach it because you gotta do some advanced stuff.
This sounds like my kind of dark sorcery that I'm going to have to play with.
Yeah,
I find with Git, once you start to dig into those features, and it really helps your workflow, doesn't it? When you can start, it unlocks a lot of things that you can do, doesn't it? And it really pays to learn those things.
yeah, I mean, it is a tool we use daily, kind of, so it does pay off to do invest some more time to learn it. Though it is really complex, like there's a bunch of stuff you can do.
Yeah. I think that's all of the questions now. So thank you for that. We'll take a couple of minutes break, and then say past, we'll start the next talk. So thank you for that. Hello again, welcome back. We're going to pick up the next talk now. So we've got Chris, who's going to talk about testing in the real world. Hi, Chris.
Hiya.
Thanks for joining us today.
Thanks for having me.
Okay, I think we've got your screen and we can see you and hear you. So do you want to kick off then?
Yeah, sure. So as has just been said, this is called testing in the real world. Start by asking the obvious question. Who am I and what am I doing here? I'm a developer at a company called Jump24 based in Birmingham. We work with Laravel and Cake PHP using test-driven development. My contact details are there. So Twitter, ccmiller2018, my email address, the personal website, the company website, and 2 links for Aweder. Aweder is a product that we have developed that is open source that helps businesses, predominantly restaurants, to get online for receiving online ordering. And it's Aweder that I'll be using as an example of testing today. So, how do you set up tests? Most people will look at a project and think tests come secondary. For us, tests come first. So how do you set up tests? PHP unit tests, we put them in a folder imaginatively called tests. we'll have a single file for testing each file of your application. So if you have a user's controller, a user's model, and a user's repository, you'd have 3 separate test files. You'll test a single function at a time. You'll test a single pathway for a function at a time. So for example, if you've got a function that returns even, odd, or 0 after assessing a number, you'd have a minimum of 3 tests for that function. And we keep it short and simple. The shorter the test, the easier it is to find out what's going wrong if there is problems. And the shorter the test, the quicker they run. So let's get straight into looking at some tests. This is a simple test from one of our models. And this is simply testing whether it's a delivery or a collection from the model. So we'll start by setting up the model with isDelivery, and we're passing in $bool. So a variable called bool and a variable called type at the top as well. The value is the value that we're testing against. So we'll run our method, get isDelivery or collection, and then we'll assert that our type is our value. But where are these coming from? So where are we getting bool and where are we getting type from? Those are coming from data providers. So what's a data provider? A data provider allows you to write one test but have multiple data sets. So you could have a test that adds numbers together and you could give it 200 data sets and you would have 200 tests, but they'd all be run through one single function that's passing in data. You can expand that data easily, so you can always add to a data provider or take data out. It keeps the file concise, so you're not repeating code consistently in the same file. You can get clearer messages on your tests, and I'll come back to that in a moment. They always return arrays, and they just simply allow you to pass data in to use in your test. So here's the example data provider for our test that we've just shown. So this first part here that says delivery is provided, that gets put onto the end of the message that comes out that tells you what test is being run. This is our bool, the true, and the delivery is our type. So in this case, we're passing in true and delivery and then false and collection. If we go back to our test, we can see that we set isDelivery to true, and then we expect our type to be delivery. We set isDelivery to false, and we expect our type to be collection. And that's just come from the simple data provider. So how do we develop tests? Well, as I said, tests come first for us, test-driven development. We will always write the test first wherever it is possible to do so. We'll keep functions as testable as possible. So we'll aim to have small, simple functions, ideally with a single input and a single output. We'll minimize data access in our tests. So we will use factories, we will use varying other methods to minimize access to the data, to the database. This helps to speed up the test and also stops pollution from previous tests if a item hasn't been cleared from the database. We never, ever, under any circumstance, access the main database. If the code changes, then we always assume that a test should break. So if we change something in code and our tests still work, the likelihood is that our tests weren't covering what we wanted. 100% coverage is not the aim of testing. The aim of testing is to have effective tests. So there may be some areas that you don't cover, but it's better to have good coverage on some areas than 100% coverage of bad tests. We'll set up our tests in the following order. We'll prepare the database if we need to. We'll define the data that we want to use. We'll run the function you want to test, and then we'll assert the response as what you want. And in our test file, we follow the flow of the function. So we'll go through a function and we'll make sure that our tests in order follow the order that things are in the function that we're testing. So why don't we write some tests for order using what we've learned? Let's have a little user story. So we wish to be able to retrieve the domain or username from an email address for our user. It should return an empty string if it's not a valid email. It should return everything before the @ if it's a valid email and a username is passed in. It should return everything after the @ if it's a valid email and domain is passed in. And it should return an empty string if invalid type is passed in. So we've got some pretty clearly defined lines here of what our little user story wants to do. In this case, it's separating the string based on what's passed in and giving us the relevant part. Time for some live code. What could possibly go wrong? So we'll start by creating, in this case, the user model test. So we'll just create user test.php. That tells us that we're testing a file called user with the model because of where it is. So it's in our unit tests, it's in models, and it's called user test. With testing, you'll always want the file to end with test. So let's start by putting in the basic shell of what this test file needs to look like. And in our case, we'll open with a PHP tag. We know we're going to be testing app user, so we'll import that. And we want it to run the standard test case from tests and test case. We've got a group here called user model. That allows us to shortly be able to limit our tests by group so that we can just run a small portion of our tests to be able to have a clearer idea of the small portions that we want to run at any given time. So let's put in our test. Now, we said earlier about data providers, and in this case, I think it's a perfect example of where a data provider would make sense. So our test, we'll test get email component will return relevant component. Our data provider needs to return the email, needs to return the component that we're going to pass in, and needs to return the expected function, the expected result. So following our pattern earlier, there's nothing in the database to set up. So we need to set up our data. We'll pass in a new user. We'll set the email of the user to the email we're passing into the function. And then we'll assert that our expected result from the data provider is the same as the get email component from our user model. So that's our test done. And it's a relatively simple test, but there's actually quite a few boundaries that we need to cover. So let's get our data provider. Our data provider needs to deal with at least 4 situations in this. So as I said before, it's returning an array. We've got names for each thing, which will help us in a moment, and we'll be able to see what difference that makes shortly. So returns an empty string if email did not validate. So our email is not an email. We're asking for the username, and we get back empty string. Retrieves the username from email. Well, in our case, we expect it to return Chris because we're asking for the username from my email address. Retrieves domain from email. Again, we're expecting jump24.co.uk as domain is being passed in on my email. and we'll expect an empty string if it's not a valid component name. So Chris@jump24 is the email, not real is the request, and we expect an empty string. So we'll just double check that we've got everything covered from our story. So if we go back to the user story, so we wish to be able to retrieve the domain or username from an email. Our test says we can do that. It should return an empty string if it's not a valid email. Our test says we can do that. It should return all before the @ if it's a valid username. If it's a valid email and username's passed in, our test says we can do that. It should return all after the @ if it's a valid email and domain is passed in. And it should return empty string if an invalid type is passed in. So yes, our test covers all of those. So if we go back and we take a look at the model, in fact, before we do that, I'm just going to run this group. So to run the tests, we use vendor bin PHPUnit because we use PHPUnit for our testing. Test docs just gives us a nice clean output that we can see on screen. And then we want to filter those. We want to run the group. So we do group user model. Now, I would expect these tests to fail. And they do. So the reason I expect them to fail is because we've got no code attached to this yet. And you can see here that our tests are coming back with the data, with the extra data at the end that tells us exactly what we're testing. So our first test, get email component, will return relevant component with returns empty string if email did not validate. So we can see here very clearly on screen, very quickly, what we're testing. So our tests are failing as we expected. If we go to our app folder, and in this case, we have a user model in here because the user model already exists. Let's have a look. So we're calling a function here, and the function we're calling is get email component. And as you can see, the tests have come before the code. So let's put in some code. So having looked at the tests and at the story, I think this kind of simplifies what code we might want to write here. And our code looks relatively simple. So it's a function called getEmailComponent. We pass in a string and we expect a string back. In the first instance, we expect we filter the string to check that it's an email, and if that returns false, we'll return an empty string. We'll explode our email array at the @. So we now know there has to be an @ there because we know it's a valid email. So we've now got an array of our components. If the component that we've passed into this function is domain, return the second item from the array. If the component is username, return the first item from the. I think now we'll have some passing tests. So if we run that, yep, we've got 4 passing tests, and that's come from test-driven development. So what if I'd made a mistake? Let's just say I put in not real. It's quite easy for us to, as developers, be working through something and cross-reference against a story and put things in that aren't quite in the story. By having the tests in place first, we can be certain that our code works. So if I run that, so now we've got one of our tests fails. So that tells me that something's wrong in my code. And if I scroll back, we can immediately find out which one it is, which is returns empty string if it's not a valid component name. So we'd come and look at our code. We know it's the last test we're running, so it's going to be towards the end of the function. Oh, and there it is. We're expecting an empty string, but that's not an empty string. So that gives us quick debugging facilities. Again, we've corrected that, and it will run. But whilst we're here, why don't we have a look at how we can run tests in varying different ways? So you've got the obvious one. We can run all of our tests at once. I'm using test docs just because it makes it clearer what we're running. So if I run this, it takes a couple of seconds to kick in, but then it will start running through our tests. And at the end, we'll get a result that tells us how many tests we've got, how many passed, how many have been skipped, how many have failed, and varying other stats that give us some idea of what state our tests are in. And as you can see, over time, test suites can build up to being quite lengthy test suites. But this all means that we've got code that we can trust, code that we know that we have tests against, and if we change something, we can expect our tests to break. And there you go, there's 248 tests run with 762 assertions and no failures and no skips. So you saw me use it earlier, which was group. So group allows us to group things together that might span across multiple files and run them together. So if I run the group user, it'll come back and tell us that there's one test. But if I run the group inventory, it'll come back and give us 5 tests. So that's a useful way of grouping things. But we also have another one in this, which is test suite. So you can have the whole of your test suite run, or you can then choose to run a smaller portion. So we have a test suite called feature, and test suites, you'll find those are defined in PHPUnit.xml, which is PHPUnit's configuration file. So if we have a look here, so here you can see we've got a test suite called unit that has a directory, looks for a suffix of test.php, and we expect it to be in tests unit. We've got one called model, we've got one called feature, we've got one called service provider, and that's the ones that we've got in here. So I can run test suite feature, and it will run through everything in our features directory. And it'll give us a result just on those tests, which is, as you can see, it's now 130 tests. When we ran the whole suite, there's 248. Or I could run, for example, our model. So, sorry, it's models. Actually, it's telling me that model has no tests. So that tells us that that test suite might need some work, and we'll take a look at that outside of this talk, but it highlights that test suites are useful. The other option that we've got is you can do filter. So filter allows us to run tests in combination by looking at file names or looking at names of tests and various other things, but most of the time it's those. So I could filter by can, and if I run that, it'll run through, find tests or files with the word can in them. So in this case, it's found fetch cancelable orders, and it ran 89 tests. Or I can do fetch cancel, which should find us that file. And again, it's filtered out based on the file name here. That just gives some insight into the varying ways that you can run tests. So let's go back and think about this a little more. There's some further reading we could look at. So I've done a very brief overview of how we deal with this, but looking at getting started in test-driven development, it's something that when I first started with this company, test-driven development wasn't something I did. But since working for Jump, I've discovered that test-driven development has helped me to improve the quality of my code and helped me to ensure that my code is right as early as possible in the flow. So there's PHPUnit, what, why, and how. That covers some pretty basic introductions into PHPUnit, some of the things that PHPUnit can do. We've got how to write testable and maintainable code in PHP. That one looks at thinking about the way you write your code to make it more usable and more easy to test. And the final one is looking at how to write tests for legacy projects in PHP using PHPUnit. I've discovered that it's never too late to start writing a test. If you have 0 tests in a project and you put one in, and that test is a good test, you've improved the quality of that project. But then you can just keep doing that. So every time you work on a section, add some more tests, keep those tests up to date, and over time you begin to have tests in place for a project that's a legacy project. I'll retweet all of these links and I'll blog the talk that I've done here as soon as we get the link at the end. But let's get some questions.
Thanks for that. Does anyone have any questions? Just stick them in the chat and we'll ask them. So the first one is actually coming from Mark, who's asked, have you ever used any other testing frameworks such as PHP spec? And if so, what makes you choose PHPUnit particularly?
So I haven't actually used other PHP testing frameworks, but I have in other languages. So in JavaScript, I've used varying different testing frameworks, Jest, Mocha. The primary reason for using PHPUnit is we're a Laravel development house, and PHPUnit is very nicely embedded into Laravel. And Laravel have given some really nice extensions on things and really nice assertions. You can run against roots, you can run against the database, and varying things just built in that really, really help.
The reason I mentioned PHP spec in particular is I believe it was particularly written towards TDD, so it was kind of designed for it.
It'll do like some code generation and stuff, won't it? For you, I've seen it, but I've never used it. It seems that everyone who uses PHP spec seems to really like it, but PHPUnit is far more popular.
It's interesting that I've always done TDD using PHP spec, but I've not used PHPUnit, so it's interesting seeing the alternative.
Yeah, does it sort of kind of guide you through the process of doing TDD, PHP spec?
Okay, so does it use the Gherkin language around that, or is it not that low level?
Bhat uses the Gherkin language.
I think is the PHP spec the one where like you'll tell it via the command line to make a test, and it'll ask you kind of what you want and sort of do some generation for you and keep on bits for you. So
Laravel does actually have some of those features as well. I wonder if they may have borrowed some from PHP spec then.
I particularly like the prophecy mocking library from PHP spec. Effectively, you type in your object in your function parameters, and it creates like a double of it, and you can test based on that double, and it's really nice way of working with mocks.
Definitely something to take a look at.
Yeah, I think PHPUnit has some kind of mock stuff built into it these days.
It does. There's also some great packages out there, like Mockery, obviously. There's Laravel has certain things built into the framework, so you can just do really simple things like storage :fake will give you fake storage. And there's so many things that PHPUnit can do that it hadn't used to be able to do. A lot of it is down to the framework that it's put in and the the code that you put into it. I mean, you can actually write your own assertion models within PHPUnit to assist with varying different things.
Have you ever had to play around with mutation testing before?
I haven't, and it's something I really want to get time to play with. It looks like something that would be brilliant.
I've used it in other languages, but not used it in PHP before. Yeah, that's quite interesting. Question from Dorothy. Any tips for mocking classes that have other classes passed into the constructor? So like turtles all the way down with your dependencies.
So I'm assuming that means like where you'd have a constructor set up, and in that constructor you'd pass in a repository, and that repository expects something else, which expects something else. Is that?
Yeah. I think that's probably what she means.
Okay, so one of the first things we try to do is to avoid passing in to constructors if we can. It's not always possible. If the class already exists, I'd look to be mocking the things that are being constructed, because if they're only being passed into the constructor, then do you actually need them for the test you're going to run? So, for example, if you're running a mapping system, and you're then testing its ability to return the name of the town, do you actually care about the geolocation constructor? Probably not. So you could just pass in a faked geolocation, but then pass in the elements that you want to test at the time. The other thing I'd be looking to do is I'd look to refactor it. So get tests in place that help you to know that the code works, then refactor it. And then if the tests still pass, then you've probably got it right. If the tests don't pass, then you probably haven't. And refactoring after tests is always much, much easier than refactoring before them.
To add to that as well, what I usually would say with if you're mocking things where you've got like a set of tree of dependencies like that, is just do the top level in that test and then try and split out into individual tests to do those other steps. So then your main unit test are only testing the top level of each one. But then I guess you can have... Sorry?
The thing I love about TDD is it basically slightly changes the way you think about coding. Because you're writing driven by the tests, effectively it structures your code in the way that will work well with tests. And it's always forcing you to think ahead instead of just diving in and kind of winging it. It basically makes you plan more, which is great.
Another thing from Dorothy, she's mentioned a tool called Callan, K-A-H-L-A-N. She says it's a nice way of putting things. Looks like a natural language.
Cool.
Kind of splits it out into that. I've just got it. I haven't looked at it now. It splits it out into those sort of definitions where you can then put blocks of code within each one. Looks quite interesting.
So that's more like the Jest style.
Yeah, like using anonymous functions. Cool. I think that's all the questions. So we'll wrap it up there. I'll be going over to the social thing. I don't know if Mark will as well, and maybe Chris. So if you want to come and continue to chat about that, just click on the social tab at the top, and we'll continue to have a chat there. But otherwise, we'll see you next time. Thanks to both of our speakers. Thanks for everyone who's tuned in and listened as well.
Cheers, guys. Thanks for speaking.